Hi, I'm teacher Aminul from YMS EduTech Learning Hub. Inshallah, we help students improve in math and science by 2 grades in less than 3 months. Today, I'll be sharing with you how to solve trigonometry problem and visualizing them using a 3-dimensional model. Now, let's take a look at the question together. In the diagram, A is a point at sea level at the foot of a vertical cliff. Two buoys, B and C, are on the surface of the sea. AB is 550 meters and AC is 645 meters. The bearing of B from A is 62 degrees and the bearing of C from A is 100 degrees. Part A. Calculate. Part 1. BC. To solve for the length BC, what I've done here, I have redrawn the triangle so that we'll be able to see the information better. So the triangle ABC is shown as such, with the side AB 550 meters, side AC is 645 meters, and the angle in between, or what we call the included angle, is 38 degrees. When we have two sides and one included angle, to solve for the last side, the third side of the triangle, we can use cosine rule to solve for the unknown side. And cosine rule is given as such, where it is a square is equals to b square plus c square minus 2bc cosine a. Now this formula is given in your formula sheet, okay, in the examination, so you can refer to the formula sheet. But you need to know what are the values to substitute in. What I've written here, I've written a line to connect the side, one of the side A and the opposite angle. So these two are what we call the angle and their opposite side. Okay. Therefore, if I were to refer to this diagram, to apply the cosine rule, A square will be the unknown side. And in this case, it will be BC square equals to, I can take AB square plus AC square minus 2AB multiply with AC cosine angle BAC. Okay, that's how we can rewrite the formula. Then we will substitute in the information. BC here is the unknown, so I will leave it as BC square first and substituting the other values. So in this case, AB will be 550 square, AC is 645 square, minus 2, okay, and cosine BAC, so BAC will be 38 degrees. So if you just use your calculator to solve for BC, you eventually will get the answer to be 399, and this is correct to 3 significant figure. Calculate A part 2 angle ACB. To calculate for angle ACB, in this case what we will use the sine rule. So sine rule again is also given in the formula list. It's written as this: A over sine A equal to B over sine B, meaning to say you have the side, one of the side, and sine of the opposite angle is the same as another side divided by its sine of its opposite angle. This formula I can do a flip. Okay, so when I flip or invert the formula, I can put my angle, the sine A, above. So this is for us to solve for question that asks us about angles. Okay, so it's easier for us to manipulate later. In this case, what we'll do, we will use, this is the unknown. That will be an angle C. Alright, so this, instead of using sine A, I will be using sine C instead. So sine C over, it will need to be divided by its opposite side. And in its opposite side, your sine C, opposite side of angle C, will be 550. This is equal to, I need to take another pair of side and angle. In this case, I will be taking 38 degrees, so sine 38 degrees over the opposite angle, which is 399. we have to do a manipulation and eventually we will solve for C. In this case, I'll bring 550 over. Sine C is equals to 550 multiplied by sine 38 degrees over 399. And then what I'll do to solve for C, I will bring my sine over. Now bringing our sine over will give us the sine inverse, the function sine inverse. So I will write over this side, sine inverse, C will be equals to sine inverse the entire value, okay, the one that I have written earlier. And key into your calculator, you should get a value of 58 degrees. A part 3, calculate the bearing of C from B. To calculate the bearing of C from B, we will first need to know which angle we are referring to. And in this case, if I want to find the bearing of C from B, I will need to start with my north line at B. Okay, so bearing of C from B, so my north line will be at B. The angle that we need to calculate will be the one measured from the north line, moving clockwise towards the line that join B and C. Therefore, in this case, we are referring to this angle. What are other angles that we know? We know that from the earlier calculation, the angle ACB is 58 degrees. And the angle here, which is 100 degrees, okay, will be split. It can be divided. Here, the top angle here is 62 degrees because that is the bearing of B from A. So that angle here is 62 degrees and the remaining angle is 38 degrees. That gives a total angle of 100 degrees. So if you look at the triangle ABC, we already know two of the angles, 38 degrees and 58 degrees. Therefore, we can find the angle B here, which is 84 degrees. Okay, and the second, what do you call this? By interior angle. Okay, by interior angle. If this is 62 degrees, this line here, the north and the north line, they are parallel. Therefore, if this is 62 degrees, then the angle here will be 118 degrees. See that? So with that, what is the unknown angle here, the remaining angle, which is the bearing of C from B? So 360 degrees, subtracting these two angles, you will get 158 degrees. B. D is a point at the top of the cliff vertically above A. The angle of elevation of D from C is 7 degrees. Calculate part 1 AD. In this three-dimensional model, I have reproduced what is being mentioned in the question, whereby D here is a point at the top of the cliff vertically above A. So this is A, D is at the top of the cliff, but D is also vertically above A, so it has to be at this point. And it mentioned that the angle of elevation of D from C, that means it's as if you are standing at C and then you are looking at point D. I have a string here to illustrate the line of sight that you should be looking when you are at point C. So if you are at C, your angle of elevation of D, you'll be looking up this way. And the angle that you are supposed to calculate for is the one here, in between here. Therefore, what is that angle if you were to write the notation? It's supposed to be angle A, C, and D. I say again, angle A, C, and D. That angle here, in between. So here I've drawn the triangle ABC. Again, D is vertically above A, and this is your point C having an angle of 7 degrees. Question asks, how do you calculate for AD? Therefore, we know that this triangle is a right angle triangle because D is vertically above A and AC is actually on the horizontal plane. Therefore, this angle is 90 degrees. We can use our trigonometry ratio. And in this case, since I know that this is my angle 7 degrees, AD will be the opposite and this side AC will be the adjacent. Opposite and adjacent, therefore we will use the trigo function tangent. So tangent 7 degrees is equals to opposite, which is AD, over 645 meters. So to solve for AD, I bring 645 over 645, tangent 7 degrees is equals to AD. Therefore, AD is equals to, you use your calculator and the answer will be 79.2 meters. 2. The greatest possible angle of elevation of D from a point on BC. To find the greatest possible angle of elevation of D from a point on BC means that I will need to find the angle of elevation from some point here on BC. And you look up at point D, but that angle will be the greatest possible angle of elevation. And when will that happen? That will happen when first you have to draw a line from point A, which is at the foot of the cliff. And this line here should touch the line BC at 90 degrees, perpendicular, here, perpendicular. That is the point. If you look from that point to D, you will have the greatest angle of elevation. So let me illustrate to you with this string here. So if I were to look up from this point, that angle, this angle here will be the greatest angle of elevation. But first you need to find this line here which joins A to the point that will get a perpendicular to BC. As you can see from the top view, we will have the triangle ABC, and if I want to draw a line, a perpendicular line from A to M, to find the length of AM, I will use this triangle here at the bottom here, AMC, because it is a right angle triangle. So I can use my trigo function to calculate for the value of AM. So for us to find the length AM, we will use this right angle triangle with the side 645 meters and the angle 58 degrees. We will first indicate where is the opposite hypotenuse and adjacent. In this case, 645 will be the hypotenuse and AM is the opposite of this angle. Therefore, since opposite and hypotenuse are involved, I will use the trigo function sine. Sine 58 degrees is equals to opposite, which is AM, over hypotenuse, which is 645. Therefore, I do my manipulation. AM is equals to 645 multiplied by sine 58, and this will give an answer of 546.99 meters. So that is the length of AM, which is 546.99 6.99 meters. To find the angle of elevation of D from M, the angle that we are interested to find out is theta, this angle here. Okay. Again, this is a right angle triangle with AM on the horizontal ground at sea level, and D is a point above, vertically above A. Therefore, if I want to find this angle, and I already know the height of AD, so in our earlier working, AD is 79.2 meters. So I already have one of the sides, in fact two of the sides where AM was found in the earlier, just the step before this, AM 546.99 meters. This is the angle, therefore being a right angle triangle I can use my trigo function, tua kaso. This will be the opposite, this side will be the opposite because it is the side opposite to the angle. This length AM will be the adjacent, right? Adjacent. Therefore, since opposite and adjacent are involved, we will use the trigo function tangent. So tangent theta is equals to opposite 79.2 over 546.99. So solving for that angle theta, our angle of elevation, tangent inverse 79.2, that will give you an angle of, using your calculator, we will get the angle of elevation to be 88.2 degrees. I hope you have found this video useful for you to visualize trigonometry problem using a three-dimensional model. I'll see you again in the next video.